Our Earth, a vibrant sphere of life, pulsates with a rhythm as old as time itself, the ebb and flow of our oceans. These immense bodies of water, covering over 70% of our planet's surface, are far more than just vast, salty expanses. They are the lifeblood of our world, a vital organ that sustains us all. From the air we breathe to the food we eat, our lives are inextricably linked to the health and well-being of our oceans. They provide us with sustenance, regulate our climate, and inspire wonder with their breathtaking beauty and diversity. Yet, despite their importance, our oceans face unprecedented threats from human activities. Pollution, climate change, and overfishing are pushing these precious ecosystems to the brink. The time to act is now to protect and preserve this vital heartbeat for generations to come. The fate of our oceans is in our hands. Let us choose wisely. Oceans, in their simplest form, are vast, interconnected bodies of salt water. Covering more than 70% of the Earth's surface, they play a crucial role in regulating our climate, supporting marine life, and providing resources for human use. The sheer size and depth of these bodies of water are awe-inspiring, with the deepest parts reaching over 36,000 feet. They are not isolated entities, but rather a single continuous body of water, often referred to as the world ocean. This interconnectedness means that changes in one part of the ocean can have far-reaching effects on marine ecosystems and weather patterns across the globe. However, for geographical and navigational purposes, we divide this global ocean into distinct regions. These divisions help us to better understand and manage the vast expanse of water, each with its own unique characteristics and challenges. The Pacific, the largest and deepest of the oceans, stretches from the Arctic in the north to the Southern Ocean in the south, bordered by Asia and Australia to the west and the Americas to the east. It covers more area than all the land masses on Earth combined and is home to the Mariana Trench, the deepest part of the world's oceans. The Atlantic, the second largest, lies between the Americas to the west and Europe and Africa to the east. This ocean is known for its significant role in history, being the primary route for early explorers and traders. It also features the Mid-Atlantic Ridge, an underwater mountain range that runs down the center of the ocean. The Indian Ocean, the third largest, is nestled between Africa to the west, Asia to the north, Australia to the east, and the Southern Ocean to the south. It is known for its warm waters and monsoon weather patterns, which have a profound impact on the climate and agriculture of the surrounding regions. Lastly, the Arctic Ocean, the smallest and shallowest, lies around the North Pole, covered in sea ice for much of the year. This ocean is crucial for regulating the Earth's temperature and is a habitat for unique wildlife, including polar bears and seals. However, it is also one of the most vulnerable to climate change, with its ice cover rapidly diminishing. These divisions, while somewhat arbitrary, help us to understand and study the unique characteristics and ecosystems of each oceanic region. By examining each ocean individually, scientists can better monitor changes, protect marine biodiversity, and address environmental challenges. The oceans are a vital part of our planet's health, and understanding them is key to ensuring a sustainable future for all life on Earth. Imagine a world without land, where the horizon stretches endlessly and the only thing you see is the vast open sea. A planet dominated by a single, continuous expanse of blue, where the sky meets the water in a seamless blend. This is the reality of our planet, with oceans covering over 70% of Earth's surface, creating a blue marble when viewed from space. Their vastness is difficult to comprehend, stretching from the frozen poles to the warm, sun-drenched tropics, encompassing a variety of climates and ecosystems. Their depths hide mysteries yet to be uncovered, with creatures that seem to belong to another world, and landscapes that are as alien as the surface of another planet. The Pacific Ocean, the largest of the five, covers nearly a third of Earth's surface. Its vast expanse is home to countless islands, diverse marine life, and some of the deepest trenches known to man. It's so vast that all the continents could fit within its basin, a testament to its immense size and scale. The Atlantic Ocean, covering about 20% of Earth's surface, is responsible for the currents that moderate Europe's climate, making it more temperate than it would otherwise be. The Indian Ocean, slightly smaller than the Atlantic, plays a crucial role in the monsoon patterns that dominate the weather in Southeast Asia, bringing life-giving rains to the region. Finally, the Arctic Ocean, though the smallest, is no less significant. Its icy waters and floating icebergs play a vital role in regulating Earth's climate, acting as a global thermostat. These vast bodies of water are not just geographical features, but integral parts of our planet's life support system, teeming with life and biodiversity. They are the lungs of our planet, producing much of the oxygen we breathe, the heart of its climate system, influencing weather and temperature, and the cradle of life itself, where life on Earth began and continues to thrive. Section 4. Cradles of life sustaining our planet. Oceans are far more than just saltwater. They are teeming with life, from microscopic plankton to gigantic whales. This incredible biodiversity is not just a spectacle of nature, but a vital component of our planet's life support system. Phytoplankton, tiny marine plants, produce over half of the oxygen we breathe, more than all the rainforests combined. They are the base of the marine food web, providing sustenance for a vast array of creatures, from microscopic zooplankton to large fish and marine mammals. The oceans absorb vast amounts of carbon dioxide from the atmosphere, mitigating the impacts of climate change. They regulate Earth's temperature, distributing heat from the tropics to the poles through currents. Their influence extends far beyond the coastlines, impacting weather patterns, agricultural yields, and even our very existence. The health of our oceans is intrinsically linked to our own. Their well-being is not just an environmental concern, but a matter of global survival. Section 5. Unveiling the deep components of our oceans. The oceans are a complex tapestry woven from various components, each playing a crucial role in the intricate web of marine life. These vast bodies of water cover more than 70% of our planet's surface, making them a dominant feature of Earth's geography and a critical component of its ecosystem. The most obvious component is, of course, the water itself. This water is not just a simple liquid, it is a dynamic and ever-changing medium that supports a myriad of life forms and processes. But this is not just ordinary water, it's a saline solution containing an average of 3.5% dissolved salts, primarily sodium chloride. These salts are essential for the survival of many marine organisms, influencing buoyancy, water density, and even the way sound travels through the ocean. This salinity, along with temperature and pressure, varies with depth, creating distinct layers within the ocean. These layers, known as the epipelagic, mesopelagic, bathypelagic, abyssopelagic, and hadalpelagic zones, each host unique communities of organisms adapted to their specific conditions. Sea ice, another crucial component, forms in the polar regions, playing a vital role in reflecting sunlight and regulating global temperatures. This ice acts as a habitat for various species, including polar bears, seals, and penguins, and influences ocean circulation patterns. Marine life, ranging from microscopic bacteria to gigantic blue whales, thrives in this watery realm. The diversity of life in the ocean is staggering, with countless species yet to be discovered and studied. These organisms form complex food webs and contribute to the ocean's health and productivity. From the sunlit surface waters to the dark, abyssal depths, life has adapted to every niche. In the photic zone, where sunlight penetrates, photosynthetic organisms like phytoplankton form the base of the food chain. In contrast, the deep sea is home to bioluminescent creatures and extremophiles that thrive in high-pressure, low-temperature environments. Finally, the ocean floor is not just a flat, barren expanse. It is a dynamic and diverse landscape, teeming with life and geological activity. It's a dynamic landscape of underwater mountains, vast plains, and deep trenches, shaped by tectonic activity and home to unique and often bizarre life forms. Hydrothermal vents, for example, support ecosystems based on chemosynthesis, where bacteria convert chemicals from the Earth's crust into energy, providing a foundation for life in these extreme environments. Section 6. Climate architects. Oceans and weather. Our oceans are not passive bystanders in the global climate system. They are powerful architects shaping weather patterns and regulating temperatures across the globe. They absorb vast amounts of solar radiation, particularly in the tropics, distributing this heat towards the poles via ocean currents. These currents, like giant conveyor belts, transport warm water from the tropics towards the poles and cold water from the poles towards the tropics, moderating global temperatures and influencing regional climates. The evaporation of seawater from the ocean surface provides the moisture for rainfall, driving the global water cycle. This cycle, a continuous movement of water between the ocean's atmosphere and land, is essential for life on Earth. The oceans also act as a massive carbon sink, absorbing a significant portion of the carbon dioxide released by human activities, mitigating the impacts of climate change. However, this capacity for absorption is not infinite, and the oceans are increasingly feeling the strain of human-induced climate change.